Hi, good morning or afternoon or evening or wherever I'm catching you today. Today, or in this video, we're going to be looking at Euler's formula, which is the relationship of the faces, the edges, and the vertices for your polyhedrons that we've been looking at. Remember, polyhedron is just the name of a three-dimensional shape whose sides are all polygons. So in class, we discussed Euler's formula, which is the relationship of the faces, the edges, and the vertices. And we found during class that if we look at these tetrahedrons, which we built, or the cube, which we built, the octahedron, there is a very distinct relationship between them. And it turns out that if we look at the faces and the vertices together, so if we look at the faces and the vertices together, which if I add them in this case would be 4 plus 4, and I consider edges, right, that every single time there's going to be a very distinct relationship. So if I consider 6 plus 8, which is 14 and 12, and by the way, this, of course, 4 plus 4 is 8, and I consider 8 and 6, which, of course, again is 14, and my edges. So every single time right here, I'm adding faces plus vertices, and right here, I'm looking at edges. And then I've got 12 and 20, which when you add them, you get 32. And then I've got 30 edges. And then I've got 20 and 12 again, which again is 32 with my 30 edges. Okay? And I'm looking for the relationship here, and it might help for you to see this as 8 instead of 4 plus 4. And I'm looking for the relationship of 8 to 6, 14 to 12, 14 to 12, 32 to 30, 32 to 30. And what I hope you see here is that if I were to just add 2 to the edges in every single case, I would end up with the faces plus the vertices combined. Okay? So note right here, 6 plus 2 is 8. 12 plus 2 is 14. 12 plus 2 is 14. 30 plus 2 is 32. 30 plus 2 is 32. Okay? So it turns out that if I add 2 to the edges, then that's going to be equal to the faces plus the vertices in every single case. And what this allows for me to do is it allows for me to find either faces, edges, or vertices when I maybe don't know one of them, okay? But I do need to know, I need to know 2 of them in order to be able to find the one I don't know. So you are supposed to work in class today on a table where I gave you 2 of the 3 unknowns. And I'm wishing currently that I had a copy of that I could throw under this camera. But I do not. So I'm just going to open it really quick so that I can sort of follow along. Actually, I'm just going to hit print here. And if you give me just a second, I know this is annoying, you can just fast forward your video while I go get this off the printer. So here is what we did in class today, and we're going to kind of look at this table here, which of course is just a version of this, but with things missing, okay? But even though we're missing some, because we know Euler's formula, we can just figure out what's missing, okay? So Euler's formula says that faces plus vertices has to be edges plus 2 every single time, okay? So if we consider this first one right here, okay, so faces plus vertices is going to be edges plus 2. So edges is the one we don't know, so I'm just going to leave E in the equation. So 8 plus 4 is 12. So edges plus 2 is going to give me 12. So I'm basically just trying to think, okay, so there's going to be some number that when I add 2 to it, I get 12. And so, I'm sorry, I did a crazy thing here. I added in my head. 4 plus 4, right? Faces plus vertices is 8. There, I'm sorry. So let's try again. There's going to be some number that when I add 2 to it, I get 8. And I can just guess, like is 5 plus 2 8, is 6 plus 2 8, is 7 plus 2 8, is, and so on and so forth. Or I can just solve this little one-step equation by subtracting 2 on both sides of the equal sign and getting that edges has to be 6. So it's sort of a quick way to do it. And then this is sort of a check for yourself, because if you add the faces and the vertices and subtract the edges, you should get 2 every single time. So 4 plus 4 is 8, and 8 minus 6 is 2. Okay? And maybe that's a way for you to work it instead. Maybe you should think to yourself, faces plus vertices minus edges is 2. So that Euler's formula becomes something a little bit different. Faces plus vertices minus edges is 2. You can work it either way you want. I tend to stick with the faces plus vertices equals edges plus 2. Okay? All right, let's do that again. So on this one, I don't know faces, so F is going to be my variable. So faces plus vertices equals edges plus 2. So in this case, faces plus 8 is equal to 14. And I subtract 8 so that I can solve, right? Some number plus 8 is 14. And it turns out that it is 6 again. And again, I can check my work. 6 plus 8 is 14. 14 minus 12 is 2. Every single time, faces plus vertices minus edges should be 2. And you can continue on in this manner. Faces plus vertices equals edges plus 2. Again, on this one I don't know edges, so E becomes the variable. 8 plus 6 is 14, again. And so I just subtract 2 to solve for E. And I get E is 12. Next one, I have faces plus vertices. See, vertices is my unknown, so vertices is going to be my variable. Equals edges plus 2. So I have 12 plus V equals 32. Subtracting 12 from V and 12 from 32 leaves me with V equals 20. And here's another one where I just want you to confirm that 12 plus 20 is 32 minus 30 is 2. So this should always be 2 over here. And one more time. Faces is my unknown. So F plus 12, faces plus vertices equals edges plus 2. So faces plus vertices equals 32. And then just subtract 12. And you're going to get faces is 20. Okay, I hope that helps. Have a wonderful day.